Okay, then let's continue with the fun speaker before we move on to the panel. That will be Miguel Herrero, Market and Insights Analyst at PVcase. And he will talk about managing data risks in the development and engineering phases of solar PV projects. Hey, Miguel.
Hey, Michael. How are you?
All good. You?
Very good. Calling from the Solar Power Europe offices, actually. Okay, cool. I can share my screen. I hope you can all see it. And yes, thank you very much, Taeyang and Trina Tracker for the invitation to speak today. My name is, as mentioned by Michael, Miguel Herrero, and I work for PVcase. Now, before diving into the thick of the topic of this very long presentation title, I wanted to give two quick pieces of additional context. The first one is that in addition to building a lot more solar every year, we are also experiencing a trend of solar PV projects utility scale PV projects really growing massively in scale. And actually across all regions, Europe, USA, and the rest of the world, we have seen a doubling of the average sizes of PV projects since 2015. And in fact, in the USA and outside of Europe, PV projects are on average twice the size as in Europe. And this is already a challenge, but we're also adding two very important layers of technological complexity, because on the one side we can see year-on-year increases in the use of trackers, and particularly a growing trend towards smart trackers and trackers that utilize backtracking algorithms. And thanks to the achievement of cost parity between bifacial and monofacial modules, we're seeing a very steady increase of bifacial module use. And according to the AITRPV, we can expect that by 2027, more than half of all modules used globally will be bifacial. Now, this brings a big challenge that we call data risk, which is basically caused by these technology trends, this increased complexity of PV projects, but also compounded by the chronic scarcity of skilled workers that we're all feeling. And in the case of the products that we develop, particularly qualified designers and engineers. So while we have these two trends, we can also see that the PV industry has to execute more and more projects in an increasingly competitive environment, delivering all of these increasing number of projects at a lower cost and with shorter timelines. What this has created is a huge demand for products, for software tools like the ones we develop, but which help automate and improve a lot of different steps within the project development, construction, operation, and maintenance. Now, the key issue is that a lot of these software tools have been developed, focused on very specific project development steps. A lot of these softwares don't necessarily always use coordinated data format and structures. And more often than not, unfortunately, they rely on static file formats, specifically PDFs, as a way to transfer information. Now, as a result, what happens is that information and data about PV projects gets lost throughout the PV project development process, which basically looks like this. If you were wondering, I might not be surprising a lot of the project developers out there, but it's pretty striking how complex all of these lines show different moments, different stakeholders across the PV lifecycle are requesting or sending information about a same PV project. And across all of these little lines, there is an ever-growing data risk that data will get lost at further stages. Now, PVcase is a software development company. We come from Lithuania, and what we do is we develop software to design, analyze, and optimize solar PV assets globally. We have four main products: PVcase ground mount, the AutoCAD plugin that everyone already knows and loves; PVcase roof mount AutoCAD plugin that we are currently launching to design CNI rooftops; Anderson optimization, site selection automation tool to help with all of the GIS analysis and needs for project developers; and PVcase yield, a next generation yield analysis tool. What we do basically is we develop these tools that deliver mission critical software for our clients, and making sure that all of these are category leading products, which help drive design standards and improve these design standards in our clients, and crucially, increasing process efficiency for all the people involved in actually having to deliver all of these increasing in number and increasingly complex PV projects. Now, in about 5 years, we've grown to be a global company. There's more than 1 terawatt worth of projects, of individual projects being designed in our tools every single quarter. We have more than 1,000 customers, 1,200 customers globally across 70 countries, and with colleagues in over 20 locations around the world. Now, how are we doing? What are we doing to address data risk? One of the key areas that we are quickly identified where we could have an impact is in the site selection to project design stages of the development. Now, traditional greenfielding of PV projects basically requires to first have a GIS team, sometimes in-house, sometimes third-party, that takes care and upkeeps a GIS server with all of the needed data to develop a project. On the other side, you have a development team, which is looking for the best sites to build projects, and who is drawing criteria of what that project needs to go ahead. The problem is that traditionally, the development team cannot really access the GIS server because it's very complex and it's upkeep by the GIS team. So what they have to do when they want to find out where to build a project is they basically send an email or give a call or an SMS to the GIS team that responds to them with the information that they need to build the project. Now, as you can imagine, this is not a very efficient system. You need to draft your email, wait for your GIS colleagues to respond, and then if there's a problem or maybe you want some more information, that process needs to happen again and again. What we want to do is basically automate this process by adding a layer, a software layer, with Anderson Optimization's Prospect platform, which basically helps the development team quickly and intuitively access the data they need in the GIS server to identify the best sites and analyze them in order to develop the projects, leaving also the GIS team unbothered to actually do what they do best, which is to make sure that the data in the GIS server is as reliable and trustworthy as possible. Now, the way we're doing this is very simple. We are adding a button in PV, or we have added a button in PVcase ground mount, which enables our users to directly import the site GIS data into AutoCAD, reducing all of this back and forth, so that every piece of data within Anderson Optimization Prospect is imported into ground mount. This includes hazards, offsets, and whatever other GIS terrain data you have access to, so that it is immediately included into your design platform, so you can get on with defining the best layout you can for your project. Now, Another area we are really working hard on reducing data risk issues is the conceptual design phase. Now, this is basically the moment when project developers are looking for the best configuration for their project, which provides the biggest financial revenue and obviously secures project funding from investors or otherwise. Currently, concept design workflows rely again on manual data exchanges between two or more separate software platforms, which notably go through 2D models. Now, this not only reduces simulation accuracy and obviously, the aforementioned issues with manual communication, but it also reduces a lot of the information contained within the 3D model that you can create in PVcase ground mount. The fact that it's a 2D model also means you have important limitations to simulate hilly terrain, trackers, and bifacial modules. And ultimately, the fact that it's a manual process is an issue because concept design relies on creating multiple iterations on the same design to find out which one is the best, and it's incrementally improving iterations. So what we are doing right now and what we've actually already done is with our yield simulation tool, which relies on 3D ray tracing to simulate the 3D environment of the PV plant. We are completely integrating the design phase and the simulation phase, helping our user design whatever project they can think of in PVcase ground mount. And basically, because 3D ray tracing fully takes into account the 3D design, we can easily simulate difficult topography, trackers, and bifacial modules and how these impact project performance. But maybe going back to the data risk topic, what we launched only a few months ago is a iteration engine, which allows users to export multiple designs scenarios into yields simultaneously, where they can all be calculated concurrently. What you're seeing on your screen is how it works. Iterations are done by both tilt and pitch for fixed tilt systems, whereas trackers only allow for pitch. All of these iterations are generated on PVcase ground mount to understand how the layout might change. And then you can automatically find all of these iterations and different scenarios in your yield platform to analyze in detail where the losses might be. Another area where we are very excited about, and I think this is particularly relevant following Kai's presentation and something we're focusing a lot of R&D efforts, is to simulate projects that use terrain-aware backtracking system, which, as Kai explained, is a very growing trend, which has very, very significant promise to unlock yield increases in utility scale PV plant. Now, currently simulating these can be quite challenging because the standard way to use 2D view factor to simulate them, but because terrain-aware backtracking target a 3D problem, namely inter-row shading between frames at different angles, you really, really need a 3D solution. And I think Kai's 3D engine really goes and shows how that worked very well. So what you can see on your screen is how our 3D backtracking works in the morning and afternoon hours, and how we are really simulating and optimizing the angle of all of the trackers in our virtual plant to increase generation of the plant. And this is something that we can already that we're working very hard to be able to bring to all of you very shortly. Overall, I think we're really with these three product integrations, we really aim to ensure that data sets and project information is easily and fully transferred between tools and across project lifecycle stages to ensure that project quality can be at the highest level for our customers. Now, a quick word on the way forward. I think we're really excited about the potential for digital twins to create single sources of truth for PV projects. Now, we are part of the very amazing, which I think was also mentioned before by Jan, Horizon 2020 Trust PV project, and led the development of two frameworks, one for conceptual framework for digital twins in the PV sector, and also for building information and modeling. Won't go into the details, but what you see on the right is basically how this looks graphically. Digital twins rely on geospatial context and geometry, functional connectivity of all of the components of the plant. Obviously, the component properties have the ability to track changes happening on the plant and are ideally based on standard and open formats. And these apply for all of the stages of the PV project lifecycle, from conceptual design all the way to decommissioning. What we see right now is that PVcase is very present in the initial parts when PV projects are digital models. But what we see is a huge potential to make sure that the information that is created in the initial stages of the project lifecycle live on as digital twins by working with all of the magnificent companies that you see on screen. And again, make sure that there is no data risk across the project lifecycle. So in two words, what we think is that digital twins will definitely be an important way to make sure that the information is not only not lost, but reused across the project lifecycle. And this is our long-term vision, this has a huge potential to increase process efficiencies, minimize data risk, and basically help us all in the PV industry be able to deliver all of these projects and more complex projects to the highest quality standards. Now that will be all from me. Here are my contact details. Make sure to scan the QR code if you would like to learn more and to have a look at all of these different products. I will be very happy to take on your questions. Thanks, Michael.